Okay guys, so today we're going to learn lesson 8-4, which is the last new section that we're going to learn before your test, which is when? Friday. Okay, Friday, February 28th is your second test of this 9 weeks. Today we're going to talk about factoring ax squared plus bx plus c. Cassie, will you close the door for me? In the previous lesson you learned you factored trinomials in the form ax squared plus bx plus c. Now you will factor trinomials in the form ax squared plus bx plus c, where a does not equal 0. So I want you to look at the examples at the bottom of your notes. What is the difference between all of these examples and the examples that we did yesterday?
The x has nothing.
Right. The x squared has a number in front of it. So yesterday, all of the problems we saw, x squared only had a 1 in front of it. And all of these problems, x squared has a different number in front of it. So when x squared has a different number in front of it, it makes it a little bit more challenging to factor. Now, the method that I'm going to teach you to factor these types of trinomials today is not the same method that your textbook teaches. So if you look at the textbook teaches to factor these using this guess and check method, which is exactly what it sounds. They want you to just guess factors of 6x and 4 and then test them until you find one that works. Now, while that method works, it just can be very frustrating because sometimes you have to try 5 or 6 or 7 different combinations before you find the one that actually works. So I'm going to teach you a different method today. Like I said, this is different than what the textbook will show you. So it's really important that you take some good notes because this will be the only resource you have if you need to go back and study. So I want you to flip actually to the back of these notes and we're going to write out the steps of factoring these types of trinomials. So the first step of factoring is to multiply the first and last numbers in the trinomial. Multiply the first and last numbers in the trinomial. So if we're going to use that example, the first example on the note, 6x squared plus 11x plus 4. The first thing you would do is simply multiply 6 times 4, which of course equals 24. The second step is to think of two factors of that product that have a sum of the middle number. So in this example, I need to think of two factors of 24 that have a sum of 11. So think about the factors of 24. Think about which ones would add up to be 11. 8 and 3 are the only ones that you could multiply to get 24 and add to get 11. Step 3, we're going to split the middle term into those two factors. So in this case, we're going to split 11x into 8x plus 3x. The rest of the polynomial will stay exactly the same. So I have 6x squared plus 8x plus 3x plus 4. The reason why I did that is so that I can do the last step, which is to factor by grouping. Just like we did yesterday, I'm going to take 6x squared plus 8x plus 3x plus 4, and I'm going to factor it by grouping. So I'm going to group the first two terms and the last two terms together. Then I'm going to find the GCF of each pair. So what's the GCF of 6x squared and 8x? 2x. 6x squared divided by 2x is what? 3x. And 8x divided by 2x? Good. What's the GCF of 3x and 4? 1. So that's going to stay the same, 3x plus 4. And now I can see that these two share a common factor of 3x plus 4. And what's left over is 2x plus 1. So as you can see, this method still takes multiple steps. When you have an example like this where there is a number in front of x squared, you are not going to be able to simply look at the trinomial and know what the factors are. Okay? Problems where you have a number in front of x squared are more difficult than when you don't have a number in front of x squared. With examples like this, you could pretty much look at it and know what the factors of this number are that add up to this number. When you throw in this number in front of x squared, it is going to take you multiple steps to figure out what the factors are. However, I like this method better than the method taught by the book because at least you know that for sure you're going to come up with the correct answer. With a guess and check method, you could go through several different combinations and still not have the right answer. So that's why I recommend using this method instead of the guess and check method. The more you practice it, the easier it will become. So let's turn over to the front page and we're just going to practice several examples of following these steps to factor. Now remember, the reason why we're using this method is because of this number in front of x squared. You do not need to use this method unless there's a number in front of x squared. Okay? For example, in 2x squared plus 7x plus 21. This is an example where I need to factor by grouping since there's that 2 in front of the x squared. So like we just talked about, the first step is to multiply 2 times 21. Multiply the first and last numbers, in this case 2 times 21, which is 42. Now you need to think of factors of 42 that have a sum of 17. So when I'm thinking of factors, I like to think about them in order. So if I was trying to figure out what the factors of 42 are that add up to 17, in my head I would go through the factors in order. 1 times 42, 2 times 21, 3 times 14. Do I need to keep going? No, because 3 times 14 is what I needed. 3 times 14 is 42. 3 plus 14 is 17. So now I'm going to take 17x and I'm going to break it apart into 3x plus 4x. The rest of the trinomial is going to stay exactly the same. 2x squared plus 3x plus 4x plus 21. plus 14x. I was like, something is not right. 2x squared plus 3x plus 14x plus 21. That's better. Now I can solve by grouping. Group together the first two terms and the last two terms. 2x squared plus 3x and 14x plus 21.
21x.
So what's the GCF of 2x squared and 3x?
1x.
So once you take out x by dividing each term by x, what's left inside the parentheses?
2x.
2x plus 3. 2x plus 3. And what's the GCF of 14x and 21? 7. Once you factor out 7 by dividing each term by 7, what's left in the parentheses? Good. So the factors of this trinomial are 2x plus 3 and x plus 7. Okay, if you look at the next one, hopefully you notice that now the middle term is negative. This doesn't necessarily change how you solve the problem. It's just something to pay close attention to. Yesterday we learned that when the middle term is negative, what does that mean about the factors? Yes, when the middle term is negative, that means that both of the factors will also be negative. That continues to be true in these trinomials. So that means that that both of my factors in this problem are going to be negative. So solve it in the same way. First multiply the first number and the last number. 3 times 16 is what? Connor, what's 3 times 16?
48.
Okay. Now, can you think of two factors of 48 that would have a sum of negative 16?
4 is 12.
4 and 12. Positive 4, positive 12? Yeah, negative 4 and negative 12. Be careful because you're looking for a sum of negative 16, so your numbers need to reflect that. So now I'm going to split negative 16 into negative 4x plus negative 12x. The rest of my polynomial stays exactly the same, so I get 3x squared minus 4x plus negative 12x plus 16. Group those into two pairs. Make sure that the negative stays inside the parentheses with the 12. So what's the GCF of 3x squared and negative 4x?
4x.
Huh? Three x squared minus 4x divided by x would be 3x minus 4. Now, in the next parentheses, notice that the first term is negative. This is a really good clue that your GCF is also going to have to be negative. When the first term in your parentheses is negative, then your GCF should also be negative. So what's the GCF of 12 and 16?
4.
4. So I'm going to take out a negative 4. So be careful. Negative 12x divided by negative 4 is what?
30.
Positive 3x. 16 divided by negative 4 is negative 4. So the two factors are 3x minus 4, and x minus 4. Okay, let's try one more. 9x squared minus 15x plus 4. So again, first multiply the first term and the last term. In this case, 9 times 4, which is 36. I need two factors of 36 that have a sum of what? Negative 15. So who can think of the factors of 36 that would have a sum of negative 15? Good. Negative 3 and negative 12. So I'm going to split negative 15x into negative 3x and plus negative 12x. And the rest of my polynomial is going to stay exactly the same. I have 9x squared minus 3x plus negative 12x plus 4. Group them into pairs. Christopher, what's the GCF of 9x squared and negative 3x? 3x. So 9x squared divided by 3x. Negative 3x divided by 3x. Now, what's the GCF of negative 12x and 4? Good, negative 4. Negative 12x divided by negative 4. And 4 divided by negative 4. So my two factors are 3x minus 1 and 3x minus 4. Okay, I want you to try the last example on the left-hand side on your own. 3x squared plus 13x plus 12. Okay, we ready? Okay, let's try it. So Wesley, what would you do first in that problem?
Find the product of 3 and 12.
Good. And what's the product of 3 and 12?
36.
Good. And what do you need to do next?
Find 2 factors that have a sum of 13.
Good. And did you find the factors of 36 that have a sum of 13?
4 and 9.
Good.
And separated 13. And then it's 3x squared plus 4x and plus 9x plus 12.
Now, one of the most common questions I get is that does it matter what order these numbers in? So some of you may have done 3x squared plus 9x plus 4x plus 12. And the answer is no, it does not matter what order you put these numbers in. Regardless of the order of these numbers, you should get the same answer at the end. Now, if you put 9x plus 4x instead of 4x plus 9x, the steps are going to be a little bit different, but the answer in the end should be the same. Okay, so the next thing you need to do is group together the first 2 terms and the last 2 terms. So Connor, what's the GCF of 3x squared and 4x? Say it again. Yeah. And what's left once you take out the x? Good. And then what's the GCF of 9x and 12? Good. And what is left when you... So the 2 factors are 3x plus 4 and x plus 3. Okay, one last type of problem I want to talk about, and that's like these 3 examples where the last term in the trinomial is negative. What did we learn yesterday about when the last term in the trinomial is negative? What does that mean about the factors? Right. One's going to be positive and one's going to be negative. That's the same in this case. When you have a negative term as your negative number as your last term, that means one of the factors will be positive and one of the factors will be negative. You need to put your computer away, please. So it doesn't really change how you solve the problem, but it's something you definitely want to keep in mind because it just throws in something else to pay attention to. So you're still going to solve this in the same way. You're going to multiply 3 times negative 4, and you get what? Negative 12. Then you need to think about factors of negative 12 that have a sum of what? Positive 11. So in order to get positive 11, one of those factors is going to have to be positive and one's going to have to be negative. So think about the factors of negative 12. 1 times 12. Okay, which one of those needs to be positive? And which one needs to be negative? So we would have negative 1 times 12. Because negative 1 plus 12 is positive 11. So I'm going to split 11n into negative n and positive 12n. So I have 3n squared minus n plus 12n minus 4. Again, the order of these numbers doesn't matter, but I will tell you it's easier if you'll put the negative 1 first, because then you don't have to worry about factoring out a negative GCF. So group those 2 together, 3n squared plus n, 12n minus 4. What's the GCF of 3n squared minus n? N, good. So when you take out n, you're left with 3n minus 1. And what's the GCF of 12n minus 4? 4. When you take out 4, you're left with 3n minus 1. So your factors are 3n minus 1 and n plus 4. So notice one negative factor, one positive factor, just like we said.